Alright, in this video we're going to talk about Lewis dot structures. Okay, and Lewis dot structures is just a pictorial way to represent atoms and their valence electrons. Okay, just to remind you, a valence electron are the electrons in the outer shell used for bonding. Okay, so the electrons on the furthest most shell, so the one that are the furthest out on the atom, that are going to be used for bonding. As you come over here, I kind of drew the top part of the periodic table over here for us, and there's a really simple way of knowing how many valence electrons something has if you're in the first two columns or in the last six. Okay, those are the ones we're going to be dealing with here when we're talking about Lewis dot structures. So, in the first two, okay, the amount of valence electrons an atom is going to have depends on what column it is in. So if it's in the first column, it's going to have one valence electron. Okay, hydrogen, lithium, sodium, potassium, they all have one valence electron. Okay? If you go one column over, you're going to have two. So you'll have two valence electrons. So that's beryllium, magnesium, calcium, all of those have two valence electrons. Then if you jump all the way across the gap on the periodic table over to boron, boron is going to have three valence electrons. Carbon then would have four, nitrogen would have five, oxygen would be six, fluorine would have seven, and then helium, neon, argon, krypton, xenon, all of them, those are called the noble gases, and they have 8 valence electrons. Okay, they are called noble gases because they have 8, and that means their shell is full. Okay, that means they don't need extra ones, they're not missing anything, they've got the full amount. And that's why they're noble, they don't react with anybody. They're neutral. Okay? So the number of valence electrons can be shown in these pictures called Lewis dot structures. And basically what you do is you find your element on the periodic table somewhere, you figure out how many valence electrons you have, and you draw them as dots around it. So for instance, what let's do carbon here. Over here we figured out that carbon has 4 valence electrons. So all I'm going to do is put my 4 dots around carbon here. There you go. That's a Lewis dot structure of carbon. Okay, it shows how many valence electrons they have. Carbon has 4. All right, and they hang out. Generally, you fill in, okay, one on top, one on the side, one on the bottom, one on the next side, and then you can go and do another one. So let's say if there's a 5th one, I put the next one here, and then here, and here, and here. Okay, so for any element, you can do this that are in the first 2 columns or on the last 6. Okay, so let's do oxygen, for example. Oxygen, if you come all the way over here, we're like, oxygen has 6 valence electrons. So I'll fill those in. We got 1, 2, 3, 4, 5, 6. Okay, oxygen has 6 valence electrons. This is a Lewis dot structure of oxygen. Okay. Well, now you might be saying, Mr. Mangan, this seems really dumb. Why would we need to know how to put dots around the cylinder? Like, we can just look it up and be like, oh, oxygen has 6. Well, okay, these are used to deal with bonding. Okay, so when you make a new compound, how do they fit together? Okay, so for example, let's just talk about water. Okay, it's 2 H's, 1 O, and let's use the Lewis dot structure to figure out how they bond together. Okay, so let's start off with the oxygen. It's the thing in the center. All right, and we learned that oxygen has 6 valence electrons. Okay, so I'm going to draw oxygen. I'm going to put the 6 in. I'm going to do it a little weird, just for this one. Okay, and so as you see here, we've got oxygen there, it's sitting there, and we've got 2 of these unpaired electrons, right? They're not together, they're just hanging out on their own. Okay, unpaired electrons are what elements use to bond together. Okay. So in water, oxygen is bonding with hydrogen, and if you remember, hydrogen, right, only has 1 valence electron. So what's going to happen is a hydrogen might float up to this oxygen, and it'll be like, hey, I've got an extra electron, I've got my 1 valence electron, and you've got 1 unpaired electron hanging out there, and what if we shared our electrons together? So I have 2, right, then I would be over here with helium. Helium has 2, right? And that would make me feel pretty good. I'd be noble then. And you would then have 7, so you'd be closer to neon. You'd be closer to the gold, to have 8 electrons in your outer shell. So let's share. And what they do is they would then share their electrons like this. And now oxygen's with a hydrogen. Okay? But water, right, has 2 hydrogens. So let's have another hydrogen pop over here. And this one also has an unshared electron. And he says, okay, oxygen and hydrogen, let's do this. If I share my extra electron with your last electron, then it would feel like you had 8. And I would have 2, so I'd be happy, and you'd be happy. You'd have 8 electrons, I'd have 2, other hydrogen over there would have 2, okay? And we would feel good. We would be all over here in this area, which is where everybody wants to be, okay? And so now water is going to be happy that way, okay? Water is a happier molecule. It has all the different elements have the full number of electrons they have in the shell. And for atoms, that gives them stability. They feel, I guess, full or something, right? So if you imagine oxygen, right, maybe a bigger guy eating a lot of food, he feels full. Hydrogen, they're a little bit smaller. They have like their little portion, right? But they seem filled too. Okay? That's how atoms bond together. Their whole goal is to try to make themselves feel like they're full. Okay? So, and they do that by sharing electrons. And it's kind of like Thanksgiving, right? The Pilgrims and the Native Americans, they all went and they shared their food so they could all eat. Same idea here. That's how it works. Okay? So let's do another one real quick. Let's do lithium chloride. Okay? So lithium has 1 extra electron, so it's going to pop out over here. And then chlorine has 7 valence electrons, so it's going to have 2, 3, 4, 6, 7. Okay, so chlorine's got 7 electrons, lithium has 1. All right, and so what they'll do is they will share and make a bond with their 2 electrons, and they will both feel full. Okay, that would be an excellent way to bond. Okay. Notice how I did this water one. I did that only because that's the way oxygen looks. Remember, if you've ever seen oxygen drawn out chemically, it looks like this. Okay? The reason for that is these unpaired electrons over here, they take up a lot of space, and so it forces the hydrogens to move down into this bent pattern so they can make space for these electrons that aren't being used to bond, and so they're just kind of partying all over the place. So just remember, Lewis dot structures are just a way to show how atoms have valence electrons. It explains how some bonding works. Some. Okay? It doesn't explain how everything works. Okay? We don't really use Lewis dot structures for compounds like this because they bond in a different way, but you can still visualize it a little bit, right, with the electrons being shared that way. Okay? Even though they don't actually bond that way. This is an ionic bond, right? This is a covalent bond. So, just remember that it's just a cool little trick that scientists use to really kind of deal with valence electrons.